So this is our last session for our Earth Day celebration, pre-Earth Day celebration. And I'm going to skip through some slides. And we're going to start with this joke this afternoon. What's the difference between weather and climate? It's also a question we ask in science class, but this one's a funny answer. Any guesses?
You're in the wait. You're waiting.
All right. You can't weather a tree, but you can climb it. I know it's corny.
I like that one.
All right. All right, next one. I just had one for that one. All right, so we're going to bring on Latanya Waller, who's our fabulous intern, and she has two activities she's going to do. And Latanya, you want to start with Barometer, correct?
Yes.
All right, so I'm going to stop sharing so she can share her screen.
Hi, so like she said, my name's Latanya. I'm a science communications intern with the National Institute of Aerospace, and I'll be talking about building a barometer. It may be hard to believe, but the air around you is pressing on your body from every direction. This is because air has mass. This powerful push, called atmospheric pressure, is measured with a device called a barometer. Weather forecasters use barometers to help them measure how the pressure will change over time. You can make a barometer in just a few easy steps. For this demonstration, you will need the following materials, and if you already have them ready at home, you can do the demonstration along with me, or tell me to slow down if I need to slow down while doing the demonstration. So the materials you need for this demonstration are a jar, a balloon, a rubber band, masking tape, a straw, a pencil, a metric ruler, a pair of scissors. Please be careful with the scissors and ask an adult for help if needed. Also, you want to use a piece of wide rule paper where the lines are drawn 1 centimeter apart for the barometer scale. If you don't have a piece of wide rule paper, you can create one by using a blank sheet of paper and drawing your lines 1 centimeter apart using the metric ruler and the pencil.
So Latanya, I'm looking at Miss Rodriguez's class, and she's passing out supplies. So let's see if she needs a little bit more time.
Okay. Thank you for doing this demonstration along with me.
And I sent a text to Laz, see if he needed to come in. He's trying to get on.
Thank you so much, Latonia. We really appreciate it. We're so happy to be able to work with you. Our kids are so concentrated. We're
It's
gonna
a pleasure working with you.
thank you. We're working on the second part of the experiments. Okay, in second grade. So we're here watching the barometer. Thank you so much for all your support.
Awesome. I think I can go ahead and can I go ahead and get started? Okay.
Yes.
First, you want to take the balloon and you want to cut the neck off near the part where the balloon gets wider. And then discard the rest of the balloon. This will make it easier for the remaining balloon's rubber to stretch over the jar's opening. Stretch the rubber over the jar's opening. Pull it tight to get rid of any creases, trapping all the air inside. Take your rubber band and secure the rubber using a rubber band. No air
All
should
right,
be able to
take
get.
take a pause.
Oh,
She said,
gotcha.
please go
Sorry.
slowly.
Okay. So we've just stretched the rubber over the top of the jar. We've pulled it tight to make sure there are no creases. And then we secured the rubber using the rubber band. This makes sure that no air gets out of the jar.
And I see them working on it. So good.
Oh, wow.
Yeah.
Cool.
What a
So I'll
great
wait
class.
until, yeah.
I love how they're helping each other. So
Great teamwork.
yeah, boys and girls, as you are working together, I love to see that you are collaborating or working together and helping each other.
Yes. And thank you for doing this demonstration.
Yeah, it looks like maybe some may have their balloons maybe a little bit too small. So maybe a
Mhm.
challenge to get it on. So
Yeah.
we need to
You
remember next
guys,
time to tell them the size, to do a bigger
you guys,
size.
a key so that you'll know where to cut. As you see the balloon, you see the neck, you see where it starts to get wide. That's about where you want to cut it. That leaves enough leftover rubber to stretch over the top of the jar's opening.
Yeah. And some they have those tiny water balloons. Some may be like a little bit too small. So we need to remember to give them a size for their balloon next time.
Also, I would wonder if Miss Rodriguez's class, when you're making your barometers, you might be able to go down to the pre-K class and show your barometers to the students in Mrs. Inando's class. So that might be a way to be able to take what you're building and go share it with some of the students in some of the younger classes too. That's a great idea. Thank you.
Definitely.
All right. Looks like I see a lot of
Has
the.
everyone gotten a chance to secure the rubber over their jar?
I see the rubber bands going on now.
Okay. Just let me know and I'll continue when they're ready. Oh, they're holding their jars up saying, hey, we're ready.
I
Okay.
think you can go on. Next step.
So now you secure the rubber over, now you secure the rubber using the rubber band. No air should be allowed to get in or get out. So it's a closed system. After that, you want to take a 2 centimeter piece of masking tape, cut it, and stick it to the end of a straw. Does everyone have their tape on the end of the straw?
She said a little bit more time. They're waving. Are you ready? We can't hear if she's trying to talk.
Oh yeah, because we have her
Nick,
muted.
you can, are you ready?
All right, they're ready. They have their tape on.
Awesome.
Good,
Awesome.
good,
Yep, I
perfect.
got mine too.
All right.
Okay. So after you cut a 2 centimeter piece of masking tape, you want to stick it to the end of the straw. Next, take the end of the straw and place it across the middle of the rubber flat, pushing down firmly on the tape to make sure that it's secure. Once done, it should look something like this.
Show the top again. There you go. All right, I see a thumbs up.
All right, thumbs up. So once we've got our straw attached to the top of our rubber, then we want to make our barometer scale. So you want to use, again, a wide rule piece of paper where the lines are spaced 1 centimeter apart, or you can make it using a metric ruler and a pencil, and you can draw your lines 1 centimeter apart. This is going to make the barometer scale. Do they have the scale made, or I can give them time to draw the lines on the paper?
Yes.
Yep, you can take the metric ruler and see where it says 1 centimeter. You can draw your lines 1 centimeter apart, going all the way across the paper like this.
Who knows the name of the lines that are equal distances apart but never touch? What do we call those lines? I think someone's going to answer.
Oh, is Mrs. Irondo Perkwalaby, is her class making it as well?
Those are the pre-K. They're
Oh, okay.
watching.
So Sharon was saying here they can take their projects and show them. Okay.
They're good listeners.
Yeah, they are.
Okay. You can go ahead.
Okay. So once you've made the barometer scale where you're going to make your readings, you want to place your barometer in a place where the temperature doesn't change much, away from windows and heaters. Make sure to take the barometer's readings on a daily basis. Soon, you'll be making your own weather forecast. Remember, at first, the straw will be level, and over time, it'll move up and down. Let me show you why. So if you look at the top here, when the atmospheric pressure is low, the weather is cloudy and rainy, and the straw points down. When the atmospheric pressure is high, the weather is clear and sunny, and the straw points up. And you'll be able to see this also when you take measurements on your scale. This is a barometer that I made a couple of weeks back. And as you can see from the dates, the straw actually moved up and down as the barometric, as the atmospheric pressure changed. So you can stick your scale somewhere and you can record the dates, or you can actually record points on this sheet of paper and make a graph of the data to see how the atmospheric pressure changes over time. Here's a barometer joke. Okay. What did the barometer say to the other barometer? It's going to be a high pressure situation. Oh, wow. Okay. Here's
Right.
my Thank you. Here's my barometer. Why don't you try making one at home using these materials? Happy pre-Earth Day, everyone. Bye.
And Ms. Rodriguez class, can you hold up your barometers? They look pretty good from what I could see. Who wants to show their barometer?
Yeah, who wants to show theirs with the straw attached? Nice. Oh, I
Very
see the
nice.
straw. You have a white straw. That's yeah, see the level of the straw. The straw is level at first, but it's gonna change as atmospheric pressure changes. It'll either move up if you have high atmospheric pressure, or it'll move down with low atmospheric pressure. And that will correspond to a sunnier day when it points upward, and correspond to a rainy or cloudy day if it's pointing down. You just made a barometer. Quick and easy. You became your own weather forecaster.
They created some great tools to use.
Yeah.
Thank you. Guys, can
No,
you
thank you.
turn on your microphone, guys? So you can explain, Miss Latonia and Miss Bowers, what you did. Thank you so much.
Thank you. Your barometers came out looking great.
Yay.
Okay. All right. So you ready to go on to your next one, Latanya?
Yes. It's just a video, but I can explain.
We can't hear you, Miss Rodriguez.
Um,
I'm gonna get it prepped while she fix her mic.
okay.
Okay, no, well, I'll tell Ellie to go and help you out. We can start with
Go to the next one.
yes, thank you.
Okay. For this next demonstration, it's a water filter, and I got the idea from a drinking straw. That's a straw that allows you to drink water from anywhere. So if you're, for instance, lost in a forest or something and you need to drink from a stream, or in a place where you don't have clean water, you can use a drinking straw, which has its own filter in it, and you can drink any type of water. So here's the video.
Watch the video.
And
Guys, okay?
you may also see it advertised as a life straw.
Yeah, life straw as well. Imagine having to drink from rivers, lakes, or ponds, like lots of people in the world do, instead of turning on a faucet or opening a bottle to get pure clean water. You'd have to find a way to remove any pollutants mixed in the water before quenching your thirst. In this demonstration, you'll make a simple water filtering device using a plastic bottle. Dirty water will be filtered through several layers of different materials. The demonstration will produce cleaner water, but not good enough for you to drink. All you need to do for this demonstration is gather some sand, small gravel, medium-sized gravel, small clean pebbles, peppercorns, cotton balls, a spoon, a pitcher, an empty plastic 2-liter bottle, and water. First, take a 2-liter water bottle and cut all around the bottle with the scissors just about halfway. Be careful with the scissors. If you need assistance, ask an adult for help. The top part.
All right. I'm gonna stop there because I saw they had the 2-liter bottles. So I want to see if they need time to cut the
They're
bottles.
doing it.
I saw a lot of 2-liter bottles on their table. I can't see now, so you guys have to look for me.
Okay, let me expand. Oh, expand this window.
So
Yeah,
I
I
just,
do. I see a bottle. Yeah.
Ms. Rodriguez's students do have the two bigger
Yep.
bottles.
What you want to do is you want to remove the plastic piece of paper, the labeling off of the bottle. That helps you cut it a little bit easier. And you can just rip that right off. It'll come right off.
Tell me when to
And,
start again.
yeah. And to cut the bottle, you can squeeze it in half to cut across. That'll make it easier for you to cut the bottle instead of cutting around it. And then after that, you can just push it in to re-expand the bottle.
And caution that it is hard to cut the bottle. I'd also like to welcome Laz has joined us. Laz, we have a pre-K group that would probably love to hear your hellos in Spanish.
All right. Let me know when um, they can hear me, or I don't want to interrupt anyone's current presentation.
So we're giving Ms. Rodriguez's fifth graders and Mr. Kaufman sixth graders a little time to actually do the work. And then as you look at the very top, you'll see to the far left, Mrs. Let me see the class.
I think it's
Mrs.
Mrs. Wallaby at the top, the pre-K class, or
No, I think it's Mrs. Iron
Irando.
Arando. So they're
Irando.
observing. Mr. Kaufman's so it's just observing at this point. But Mrs. Ironando, we're not saying that correctly, but that's the pre-K group. But so Laz, you might just want to say hello to them while we're giving Mrs. Rodriguez's students a little time to catch up.
All right. Perfect.
We're ready. Pre-K is ready. Thank you.
All right. Hola a todos, bienvenidos, buenas tardes. Mi nombre es Lázaro, soy con el equipo de NASA eClips, con la señora Sharon y Latonia y John. Quería saludarle a todos y darle muchísimas gracias. Y nosotros, el equipo entero de NASA, estamos bien agradecidos para ustedes pasar un tiempo de su tarde con nosotros. Estamos bien felices con todos los resultados que ustedes están haciendo hoy y todo el trabajo duro que están haciendo juntos. Latonia ahora está enseñando cómo se puede hacer un filter de agua para uno en su casa, o en la clase pueden enseñar cómo pueden limpiar agua y filtrar todo el agua que uno toma. And then for my eClips team, I just told them good afternoon. I introduced the team in Spanish. And I also shared with them what they're seeing on the screen right now, that Latania's, how she made a water filter so she could use it in her classroom. They could do it at home with supervision, or in the classroom. And what is the purpose of a water filter?
Thank you, Les.
Of course, guys.
Gracias.
Latanya, I think you can continue. I think Mrs. Rodriguez's group is ready to go on.
Okay. John, I guess, yeah, we can press play. Filter. The bottom part makes a holder for the top and collects the filtered water. Next, if your bottle has a cap, remove it. Tightly pack the cotton ball into the mouth of the bottle. This will trap very small pieces of dirt floating in the water. Next, put the top of the bottle upside down into the bottom part of the bottle.
Okay, I'm going to pause there and let me know when to press play again.
Did everyone put their cotton ball at the end of the bottleneck? So everyone's done cutting their bottle. You want to take the part of the bottle with the bottleneck and press the cotton in the wedge of the opening of the bottle. Yeah, like that.
All right, ready?
Yep.
No, I went too far.
Top of the bottle upside down into the bottom part of the bottle. Now add a layer of sand about 2 centimeters deep. Make sure the cotton ball is completely covered with sand. Next, add a 1 centimeter layer of small gravel and then add a 2 centimeter layer of medium sized gravel. Remember, the more layers you add, the cleaner your water will get as it filters down. In addition, the more compact the layers, the slower the rate of filtration. With that in mind, let's use our fingertips to push the gravel and sand beneath it. The compacted layers will slow down water flow and trap lots of dirt. Finally, add small pebbles on top. Now that your water filter You need to
Just-
turn up the volume.
you need to make some dirty water.
I'm sorry. Oh, they asked, could we turn the volume?
Turn it up.
Mm-hmm.
Yep.
Oh, the
And then-
material that goes first is the smaller size gravel. And then, well, I'm sorry, the material that goes over top of the cotton is the sand. And it's measured out at 2 centimeters, but it could be more to make sure you cover up the cotton ball. So that's the first material that you put down. Yep, cotton ball, then sand. Then small gravel, on top of the small gravel, larger gravel, and then lastly, the pebbles. This is so cool. They're making it.
And the other groups that aren't making it, they can design it on paper and what they would put in theirs. If they would put other materials, they may want to test something else. So they could draw how they would design their water filter.
He says, okay.
They're ready? Okay.
Fill your pitcher with water and add as much pepper as you like. Your water is now well and dirty. Pour some dirty water on top of your pebbles, on top of your filter. Watch as the water trickles through the layers and emerges much cleaner at the bottom. Water always finds a way through the gravel, sand, and cotton balls. The gaps or pores between these layers trap the particles that are suspended in water. Remember, your filtered water is not safe to drink, even if it looks clean. This is my water filter. How many layers will yours have? Imagine having to.
So Last, did you want to make sure they understand not to drink it?
yeah, so they are not allowed to drink it at all, or they're not allowed to drink it in this step.
Not allowed to drink it at all. It's not clean enough for them to drink. Yeah. Basically just warning them to, in the video I tell them the water is clean but not clean enough to drink.
Got it. Ok, quería explicarle para ustedes que hablan español en que no pueden tomar el agua Simplemente este video están enseñando cómo se funciona un filtro de agua y cómo se puede usar, pero todavía no es un filtro que se puede usar para tomar el agua en realidad. Simplemente como para enseñarle a ustedes cómo es el proceso y cómo funciona. So I stressed with them, team, that is more for the process, even though one would think that it would work. In reality, it's just for them to understand the layers that go into filtering a water and how one is built, but to please not drink it.
And so this one shows how the big particles, or even in this case, smaller particles of pollution gets trapped, but it doesn't go through the process of testing for germs, or also in our water, it's a chemical process to clean it as well, to make it drinkable.
Got it.
Okay, I'm gonna stop sharing so I want to see the filters. How are they doing? All right.
Does anybody want to show their filter in the camera?
Yeah, I see one on the table. Can we see that one? All right, she's still helping. All right. Any questions for Latanya and her water filter? Thumbs up if you would try this at home. Oh, good. I see some thumbs up. Thank you, Mr. Kaufman's group. Who's made a water filter before? Have they made one before?
Oh, we can't hear you, Mr. Kaufman. You're muted. You're muted.
We have not tried this, but we love the idea, and there's a lot of bodies of water nearby us that we would like to test. So we're going to use this idea and like test the water beforehand and then test the purified water afterhand. I think that'd be really cool. So thank you for the ideas.
Cool.
Yeah. And for the older kids, like Latanya, you actually saw the actual, I don't know if Mr. Kaufman ever seen that life straw that hikers carry, or
Yes.
people who are traveling to other countries
So this
too.
is an actual idea that's on the market. So they have, life straws for, like Joan said, for hikers, people who are lost out in the wilderness, or they know they're not going to be able to find a fresh fresh water source. So they know that they'll probably have to drink from a stream or a pond or something. So you can just crack open the life straw and just drink directly from it. But again, the life straw has things like chlorine tablets and a couple of other chemicals, charcoal, to process it to make it cleaner.
Okay. Well, this was our last session of the day. And I'm impressed with how well the students worked on their projects and what they in our student presenters. I just want to give a big thank you to. And I especially appreciate our international friends for joining us today. And I think Mr. Kaufman's in Iowa, did he say? Iowa, and we got California, Florida, New Jersey. Florida, New Jersey. So thank you guys for joining us. And you can reach out to the NASA eClips team anytime if you need some resources, ideas for summer activities. We have a document we can share with you with activities that are 15 minutes, 30 minutes, 60 minutes long. So you get to pick interactive activities. Sharon, do you want to add something?
I just once again want to thank Mr. Kaufman's been with us all day. We appreciate that very much. Many of the classes from Wallaby School have also joined us for most of the day, so we're really thankful for that as well. If you continue to build and do any of these projects, please share images. You can share them once again on the Padlet or send them to us and we can share them through social media. But our pre-Earth Day celebration was purposefully before Earth Day so that you can go out on the day before or Earth Day itself and celebrate our Earth and encourage those around you in your communities to do whatever they can to make sure that we keep our Earth protected. Joan's sharing that NASA is going to be celebrating from April 22nd to the 24th. There'll be several different events. It's going to be a hybrid event, so you can join them virtually. If you're in the DC area, it's very exciting to actually be there in person as well. So again, thank you so much for joining us. I'm going to stop the recording. Joan, do you want to wrap us up?
I think that was it. Oh,
Hi, everybody. Welcome to Tours and Science.
yes, I do. So, I was trying to find, and for those who didn't see it earlier, here is the new Earth Day poster, and we will send out a follow-up email with links to our resources, including the Earth Day posters. Later, once we have all the media release forms, we'll send out the recordings of the presentations from today. I think that's all I have. Latanya, anything you want to follow up with as part of our team member?
Just to say, as a part of a team member, I'm glad to be here as an intern and glad to do these projects and able to share them with you. And I'm excited that your class even, had the materials ready and did them. So thank you so much and happy pre-Earth Day.